Hello everyone, welcome to the channel. This is Fahad Mirza, and in this video we are going to have a look at a very foundational model from Apple called as AIMv2. This model is not your run-of-the-mill text to image or vision model. Rather, this model helps in improving the pre-training of vision models. This model is a new method for pre-training of large-scale vision encoders. So in this video, we are not only going to install this locally and play around with it. I'm also going to give you a rundown, a brief about the core concepts behind few of the things which we are going to look at its architecture in very simple words, and you don't have to be any you don't have to have any knowledge of machine learning or AI in order to understand it. Now, let's set the stage. First, try to learn what exactly this model is doing, because that is only when you are going to enjoy it. So, building on recent advancements in an autoregressive pre-training of vision models, this new framework AIMv2 is for multimodal setting, which means both images and text. This AIMv2 is a family of generalist vision encoders characterized by a straightforward pre-training process, scalability, and remarkable performance across a range of downstream tasks, which is generation. Now, look at this diagram which tells you the whole story. So this AIMv2 is not just a single model, rather a family of models in different sizes, different variants like large, huge, small, 3 billion, 1 billion. We are going to have a look at huge one. Even the huge is not that huge. It is just like a couple of GBs, and I will shortly show you. So that is what this AIMv2 is. Now, on the left hand side, there is some benchmarking information which I'm not going to go into, but at the crux of it, the aim and objective of this model is to outperform OpenAI CLIP and SIGLIP model on majority of multimodal understanding benchmarks. A real interesting thing is happening on the right hand side, especially on the top right diagram. Now, if you look at it, you will find some of the terms which seems quite, I would say, complex, but let's try to understand them. First and foremost, as I said, that this AIMv2 is an vision encoder. So what is vision encoder? A vision encoder is a model, an AI model that looks at image or video and turns it into a special kind of information that the model can understand. It's like a translator that helps the model make sense of what it is watching. That is what vision encoder is. So it helps model to actually see the image. Then we have something called as this pixel MSE loss. MSE stands for mean squared error. This loss is a way to measure how well an AI model is doing at creating images or videos. It looks at how different each pixel is between the real image and the one that the model is created. A lower score of this MSE means the model is doing a great job. And of course, higher means model is not really good enough. Then we have something called as cross entropy loss. This loss is a way to measure how well an AI model is doing at classifying things into categories. It looks at how confident the model is in its answers and how often it is correct. A lower score again means that model is doing a good job. Then we have something called as causal multimodal decoder. This is a part of an AI model that takes the special information from the vision encoder and turns it back into the images, videos, or text. It is like a builder that uses the instructions from the encoder to create something new. Now you understand what exactly these terms are. So what is happening in this image? If you see here, if we start from this left, image patches are processed by a vision encoder trained with a prefix attention. The resulting visual representation are then concatenated with the text of their corresponding captions. This combined multimodal sequence is then processed by a joint decoder. The model is pre-trained to autoregressively reconstruct the shifted input, which means that it is reconstructing it on the basis of the previous input or previous values, and then it just goes on, and then it provides you the resultant image. That is what is happening here in simple words. So I hope that this was useful. Let's now go and try to get it installed. Before I move forward, let me introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page. It is resilient, it is reusable, and it structures the output according to the shape of your query. Okay, so that is AgentQL. This is my Ubuntu system where I'm running Ubuntu 22.04. Let me, as usual, create a virtual environment. This is going to take a minute, so let's wait. Now let's install the prerequisites, which include Torch, Torch Vision, Torch Audio, Pillow, and that sort of stuff. And now let me launch my Jupyter Notebook in the browser. Let's download the model now. I'm just using that Hugging Face processor with it, so let's wait for it. It is going to download the model. There you go. So, and these models are not huge, so it says huge in the name, but because they are just the pre-training models, the 2.72 gig is not big enough, which is quite good. And the model is downloaded. Let's see how we can use it. So I'm just using this image, and this is how this image looks like. These are just two cats. We are going to process it through this model, and then what is happening is I'm just passing it through the processor, which encodes the image with the tokenizer, and then model generates the output. Tokenizer decodes it back, and then we are printing the output here. So let me run it. And this is the output of the model, as you can see. Let me explain what exactly this output means. So if you look at here, these are the tensor values, but let's start from here. So this base model output with no attention, this is the output class of the model that indicates that it doesn't have any attention mechanism. Then this is where all the magic is happening, last hidden state. It is a tensor representation of the last hidden state of the model, which captures the most abstract and high level features of the input image, which I showed you of the cats. And this is all the tensor data. Now, it is a 3D tensor with a shape, one sequence length, and embedding dimension, where one is the batch size, because we are only processing one image. Sequence length is the number of patches or tokens the image was divided into. So, and then we have embedding dimension, which is the dimensionality of the embedding space. So in simple words, all of these values in these tensors are representing the model's abstract representation of that input image which I showed you. So this image is in abstract way is getting represented in this numerical representations or vectors or embeddings. Now these numbers can be used as features for downstream tasks such as image classification, object detection, or segmentation. For example, if you want to compare these values, for example, you want to compare two images. One image is of cat, the other one is dog. Now, with the help of these values, because these are the numerical representations, if the numbers are similar, it means images are similar. So that is how it becomes so easy for these models to do the image comparison, image classification, detection, and segmentation. So, and I have covered a lot of models around it. If you are interested, you can search it. So, but I think this model not only tries to make it easier, but the quality is better, and you can see that it is quite lightweight too, even if it is a huge size. So it is rivaling OpenAI's clip models and the SegLip models. Let me quickly show you the VRAM consumption too. So you see, it is not even consuming any VRAM, and I have 48 GB of VRAM on this NVIDIA RTX A6000. This is the GPU card I'm using, courtesy Massed Compute. So they are sponsoring the VM and GPU for this. If you're looking to rent a GPU on very affordable prices, I have dropped the link to their website in video's description with a coupon code of 50% discount. So please check them out. I think you will be very pleasantly surprised. So that's it. I hope that you enjoyed this Apple's AIMv2, not only to see it in action, but also to understand what exactly is meant by different terminologies and how it works. If you still have any questions, let me know. Happy to help out in the comments, of course. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.